Hello, welcome to this video. So this video will be about a conventional question in paper 1 of DSE about application of trigonometry in three-dimensional space. ABC is a thin triangular metal sheet. So where is it? But here you can see in part B the thin metal sheet again. So a thin metal sheet and then same, right? So that's why we try to make use of the figure 2 in part B. BC is 24, okay, and then BAC is 30, and then angle ACB is 42. And then we are asked to find AC. AC is this. So that's why we need this angle. And then a pair of sides and angles. So that's why, okay, in part A, we want AC. Sine AC, so that would be 180 minus 30 minus 42 equals to 24 over sine 30. It'll be 48 on the right, right? 48. So times a sine 180 minus 30 minus 42. So AC will be 45.65 and then 07127 XCM. And remember this, okay, so we need to save this, okay, to A. And that's for A. And then for part B1, find the distance between C and F. We need this part. Look at the wording. So it's held such that only B lies on the horizontal ground. D and E are points lying on the horizontal ground vertically below the vertex A and C respectively. So that means D and E, okay, will be the projection of points A and C respectively on the horizontal ground. AC produced it meets the horizontal ground at the point F, okay. So, well, that's key. AD equals 10 cm and CE equals 2 cm. So here I would like to join DE and F. Yes, and then I'm afraid this is a pair of similar triangles. Since AD is perpendicular to DF and CE is also perpendicular to DF. Right. So that's why here, okay, in part A, we have AC. AC in part A. So that's why for B1, so that should be simple. CF would be over AF. And then in particular AF also, that will be AC plus CF. And then AC, okay, we have, which I highlight. So AC is in part A, and then equals to 2 over 10 or CE over AD. Right. And then this is 2 over 10. So after that, we try and make AC as the subject. So in that case, 2AC equals to 10 CF minus 2CF. So AC or CF, 4CF equals AC. So that's why AC, we just try to make use of the answer in part A. So CF equals to the answer, okay, in part A divided by 4. So that will be 11.4126.782. That's in part B. So don't forget to save the answer. So and then this is part B. So in part B2, I want to find the area of triangle ABF. Good. So to find this, okay, now don't forget, okay, we have AC and then we have CF. So that's why for AF, so we know the answer. And then we have the included angle. So that's why we only need to find AB. Okay, so that's why, okay, to find AB, so that's easy because this is AB and then corresponding to this angle. So B2, first of all, we try to find AB. And then equals to BC, which is 24 over sine 30. So AB equals 32.11826911 cm. And then now we have AB, so that's why the area of triangle ABF equals to 1/2. So AC plus CF and times AB and then times sine 30. So which is 1/2 again. And remember to use the answer saved in part A and part B1. So that's why 458.194 VV69 cm squared. And that's part B2. Remember to save this. So this is it. Save answer C. Good. Okay, so B3. So find the inclination of the thin metal sheets ABC to the horizontal ground. But note that the thin triangular metal sheets ABC, okay, so only the vertex B lies on the horizontal ground. So that's why it seems that, okay, no line of intersection. But here, okay, so if we try to extend the plane ABC to the plane ABF, I'm afraid, okay, the two planes, okay, will have the same inclination because I just tried to extend the triangular plane ABC. So that's why here the line BF, we try to have this line, okay, in B2, and we try to make use of this line. I'm afraid this line, okay, will be the line of intersection between ABC and the horizontal ground. So that's why here we try to, along this line of intersection, we try to find the points, okay, and then we have the two normals, okay, of the two planes, and then the angle between the two normals, okay, will be the angle or the inclination between ABC and the horizontal ground. But here, okay, we need the height, the normals, so that's why I'm afraid, okay, we need to extend this. We try to extend this line Alright, so to somewhere H such that AH is perpendicular to BF. Okay, so that's why first of all, okay, we try to have this. We try to put here H is a point on FB produced such that AH is perpendicular to BF. And then the required angle would be angle AHD. This angle. Because DH okay will also perpendicular to BF according to the theorem of three perpendiculars, because AD is perpendicular to the horizontal ground. So that's why here I'm afraid okay we only need to find we need to find AD. AD we got, so AD is here. So AD is 10. This is 10. And then we need to find AH based on the given hints okay from B2. Already okay we have the area. So that's why okay if we have we can make use of the Heron's formula. Right now the area is already given, right? So that's why okay we need BF. Now first of all we need BF. So don't forget AB, we have the answer. Okay, we need to find the answer in the previous part. And then AF we also have. So that's why we just try to make use of the cosine formula, okay, to find BF first. So in this case, BF will be equals to AB squared plus AF squared minus 2 times AB times AF, and then cosine 30. Oops. A squared and then plus A plus B all squared minus 2 times everything we try to use the answer saved in the calculator, except the angle cosine 30. And remember to square with the answer. Good. So that will be 33.36690,449. Okay, maybe you try to save this answer, some intermediate answer. And then we try to make use of the answer in part B2. So we have the area. Okay, I put it here. And this is B3. So AH, right, so we have BF and then times AH divided by 2. So that would be the area okay we find in part B2. So in that case AH that will be 27.46400026 cm. And then after that, now okay we have AH and then we have AD. Don't forget this is right angle, so that's why okay that would be sine, right? So that's why sine angle AHD equals to AH over 10. And that's why angle AHD, so just over 10 over 10. Oh, swap it. 10 over AH. Good. And the R sine, so that will be 21.3 degrees, 21.4 degrees. And that will be for part B3. Okay, finally, we have the last part, B4. The Crossman claims that the area of triangle BDF, where's BDF? So it's an arbitrary one, right? BDF, okay, it's like this. Okay, so that will be this triangle. Right. So, do we have BF? Where's my BF? BF. Let me check. Find in last part, right? Oh, luckily I saved. Okay, so we have BF. Okay, find in last part. And then do we have BD? No, of course not. DF also no. But don't forget BD is horizontal. So that's why if we have AB, if we have AD, so first of all, okay, in B4, in triangle ADB, so AB squared will be equals to BD squared and then plus 10 squared, and then we can have AB. So BD. So yeah, 30.521848 cm. Right, and this one I'm afraid I need to save it to M maybe. Good. And then we have triangle ABD, and then we have AFD. So similarly, we have AF squared equals DF squared, and then plus 10 squared. Okay, so DF, okay, in this case, so that will be 56.180 9 cm. And then now, okay, all the three sides, okay, of the yellow triangle BDF, okay, has been found. So that's why here we try to make use of the Heron's formula. So we have S equals to BD plus DF plus BF over 2. And then that will be 60.0345. Just save it. Just write it out. And then so that's why the area of triangle BDF, we try to make use of the Heron's formula, the square root. So S times S minus BD times S minus BF times S minus BF. Now here, okay, so don't name the size wrongly, otherwise, okay, we will not given the marks, okay, about the Heron's formula. So that's why final answer And that would be 426.741482 cm square. And that is less than 460 cm square. So that's why, okay, the claim is disagreed. And that's all for the last part, as well as the whole video. Thank you for watching.